Good morning, students. Hope that you're all fine and studying your lessons properly. In the last class, I informed you regarding a class test from second lesson. Nobody responded to me positively. No problem. In my next class, I think day after tomorrow, there's a period for me. So I'm going to conduct a class test in that period. So prepare well. Only from second lesson. Now let me continue with the metals and non-metals. Next topic is how do metals and non-metals react? So in order to understand this concept, let's go back to the 9th standard, whatever we studied. We know the noble gases like helium, neon, argon, krypton, xenon, radon. Helium atomic number is 2. Electronic configuration is also 2. So K shell contains 2 electrons. Neon atomic number is 10. So electronic configuration is 2,8. K shell 2 electrons and L shell 8 electrons. Argon atomic number is 18. So 2, 8, 8. 2 electrons in the K shell. L shell also 8 electrons and M shell also 8 electrons. So if you observe the electronic configuration of these noble gases, we can see that the outermost electrons are fully completed with 8 electrons, except helium, which contains 2 electrons. So we can say that noble gases are least reactive because they have a completely filled shell. We also studied in 9th standard that if a metal or a non-metal, if it want to gain stability, it should either lose electron or it should accept electron. If a metal loses electron, we know it becomes a cation, which is positively charged. And if a substance gains electron, it becomes an anion, which is negatively charged. So the tendency of metal, non-metal is either to donate electron or to accept electron in such a way that it should attain stability. Now, consider this metals, sodium, magnesium, aluminum. We know these are all metals. Sodium atomic number is 11, so configuration is 281. K shell contains 2 electron, L shell contains 8 electron, and M shell contains 1 electron. Similarly, magnesium 282, aluminum 283. So sodium contains 1 electron, magnesium contains 2 electrons, and aluminum contains 3 electrons in the valence shell or in the outermost shell. Now, see the example of a non-metal. Nitrogen, atomic number 7, so 2,5. 2 electrons in the K shell and 5 electrons in the L shell. In the case of oxygen, atomic number 8, so 2,6. Fluorine, atomic number 9, so 2,7. And chlorine, atomic number 17, so 2,8,7. 2 electrons in the K shell, 8 electrons in the L shell, and 7 electrons in the M shell. So, if sodium is losing 1 electron, sodium will become Na+. That is sodium cation, which is more stable than neutral sodium. Magnesium, if it loses 2 electrons, why magnesium is losing 2 electrons? Because in the outermost shell of magnesium, there are only 2 electrons. And if this magnesium loses 2 electrons, magnesium will become Mg2+. And the configuration of Mg2+ will be 2,8 only. That is 2 plus 8, 10. This configuration is similar to neon. And hence, Mg2+ is more stable. In the case of aluminum contains 3 valence electrons. So aluminum, if it loses 3 electrons, Al will become Al3 plus aluminum cation. What is the configuration of aluminum cation? 2,8. That is 10 electrons are there in the outermost shell, and that configuration is similar to neon. Now let's see the case of non-metals. Nitrogen. If nitrogen is gaining 3 electrons, why nitrogen has to gain 3 electrons? Because outermost shell contains 5 electrons. 8 minus 5 is equal to 3. Okay. So if nitrogen is gaining 3 electrons, N will become N3 minus nitride ion. That is the anion. Okay. And its configuration will be 2,8. That configuration is similar to neon, and hence it will be stable. Similarly, oxygen has to gain 2 electrons, fluorine has to gain 1 electron, like that. Let's see the case of chlorine. Atomic number 17. So M shell contains 7. So if chlorine is gaining 1 electron, Cl will become Cl minus chloride ion. That is the anion. This configuration, then what is the configuration of chloride ion? 2, 8, 8. This configuration is similar to argon. 2, 8, 8. Hence, Cl minus is more stable. Now, let's see the formation of an ionic compound or an electrovalent compound like sodium chloride, magnesium chloride, etc. This is very, very important for your examination point of view also. So first, let's see the formation of sodium chloride. In the case of sodium chloride, sodium will be there, chlorine will be there. These are the two elements present in sodium chloride. So sodium, neutral sodium, atomic number 11. So electronic configuration is 281. If outermost shell contains 1 electron in sodium, so sodium is ready to lose 1 electron to gain stability. So sodium, when it is losing 1 electron, Na plus plus 1 electron. So this is sodium cation. Okay. Then what is the configuration of the cation of sodium? Na plus 2,8. Then its configuration is similar to neon. Hence it is stable. Similarly, see the case of chlorine. Chlorine 287. If this chlorine is gaining 1 electron from sodium, Cl will become Cl minus. Then what is the configuration of Cl minus? Chloride ion 288. Its configuration is similar to argon. So Cl minus is more stable. Now let's see the formation of sodium chloride. Sodium 1 electron is shown. Why only 1 electron is shown even though the atomic number of sodium is 11? 2, 8, 1. Only the electrons which is present in the outermost shell is only showing here. Okay. So 1 electron is fully transferred to chlorine atom. So 2 plus 2, 4 plus 2, 6 plus 1, 7. So outermost shell of chlorine contains 7 electrons. That is shown by a dotted mark. And one dot is present here which shows 1 electron of sodium. So sodium transfers 1 electron to chlorine. So Na will become Na plus. Then Cl will become Cl minus. So what is the now number of electrons present in Cl? 2 plus 2, 4 plus 2, 6 plus 1, 7 plus 1 electron from sodium. So 8. So this is the formation of sodium chloride. Now let's see the case of magnesium chloride. Magnesium, atomic number 12, 282, loses 2 electrons to form Mg2 plus cation. That is magnesium cation. The configuration of magnesium cation is 2, 8. Then chlorine. I just now explained chlorine 287 plus 1 electron gives Cl minus. So configuration will be 288. In the case of magnesium chloride, we know MgCl2, 2 chlorine atom will be there. Okay. So magnesium, 2 electrons shown by dotted dots, 2 chlorine atoms, 1 chlorine atom, second chlorine atom. 1 electron is fully transferred by magnesium to this chlorine. Another 1 electron is fully transferred to this chlorine by magnesium. So magnesium lost 2 electrons. So Mg becomes Mg2 plus. Chlorine 2 atoms are there. So 2 Cl, then 2 plus 2, 4 plus 2, 6 plus 1, 7. So 7 electrons which is shown by into mark. Then 1 electron from magnesium. multiplied by 2. The 2 is put outside. So this is a formation of magnesium chloride. Now we can say that in the case of sodium chloride, sodium is a metal, chlorine is a non-metal. In the case of magnesium chloride, magnesium is a metal, chlorine is a non-metal. So this type of compounds are called ionic compounds or electrovalent compounds. So in the case of an ionic bond formation or an ionic compound formation, one will be a metal and another will be a non-metal. The metal transfers electron to the non-metal. Okay, same is the case for magnesium chloride also. So this is about ionic compound formation. This type of questions are very important for your examination. So write and practice well. Next, we will study the properties of ionic compounds. If there is any doubt, please clarify. Then only I can go to the next slide. And don't forget, next class I am planning to conduct a class test. Thank you.